100 years ago, Nikola Tesla made actually a great prediction. He said that at some point we would have devices that will fit in our hand and that will give us access to the whole knowledge of mankind. And actually, he was spot on. What he didn't see was the environmental cost that would incur. Data centers and clouds are actually having a relationship with the global warming and a number of environmental damage. So there is a need for a change. And some companies have started to change. Orange has made a great improvement for the last few years. And we have the chance today to have Thibaut Favier, Green IT Manager at Orange, who is going to tell us what Orange has been doing for the last few years to improve on this part. That will be the first part of this session. The second part will be managed by Valentin Bondio, Customer Sustainability Architect at VMware, and he will focus on HPM. It's a vSphere feature that has been used by Orange, and it's a feature that you all have in your data center. It's a simple feature that can reduce potentially between 9 to 15% of the electricity being consumed. So it's a very interesting feature, and we will focus on the second part on this. If we have time for the questions, we may have time for the question, but if not, we'll be available at the end of the session to discuss. Okay? So without further ado, Thibaut, please enlighten us.
All right, thanks. Test? All right. So very happy to be here to talk about sustainability and what we do at Orange. I am Thibaut Favier, Green IT Officer. So next button. Okay, many French people here I know, but I have to introduce my company. So let me introduce it. Orange, we are a French multinational company, strongly implemented in France, of course, Middle East, Africa, and Europe. Our core business activity are to provide internet and 4G cellular networks. But we also are operating as satellite activities, cable submarine, and cyber security. Because we are big, okay, as shown here, we are big, we have to take our part and we have to be more environmentally responsible, right? So that's why I'm here. We are gonna talk about sustainability and what we do at my company. So on the first part, I will talk about our goal at the company level, all right? And on the second part, I will talk about what we do to reach this goal on my entity level. And on the third part, I will talk about what we do at my team level and some of my activities. Okay, let's start. So the big point for the company on his environmental commitment is to reach a net zero carbon by 2040 on all scopes, right?
Yeah, Thibaut, net zero carbon, I think it's a big thing.
Yes.
So what does that mean?
What does that mean? All right, let me explain you some stuff. First, okay, friendly reminder, scope 1, what is it? Scope 1 are those emissions that a company makes directly, okay? For instance, burning fuel from vehicles. Whereas scope 2 are emissions that a company makes indirectly, but with its own assets. Like, for instance, emissions generated by the power needed of your data center. And finally, scope 3 are emissions where we are indirectly involved, all right? Like emissions generated by the action of manufacturing equipment and purchased by the company. And what does net zero carbon mean? It means that we want to reduce our greenhouse gas emission of minus 90%. It's okay for the mic? Is it okay? All right, sorry. So reducing our greenhouse gas emission of minus 90% with 2 milestones in 2025 and 2030, all right? So you will probably ask, oh, I have to say that this is quite different as neutral carbon. Okay, neutral carbon, it means that you are balancing out your greenhouse gas emission. But we plan to reduce them. And you will probably ask me, how do we proceed to reach this goal? And I will say that I could say that we are working on collecting more used digital devices, or we are working on investing in a natural carbon 6 project. But I'm going to skip this part because I want to spend more time on what we do at the lower level of the entity. All right? So this leads me to the second part of the presentation. And let me introduce my entity. So roughly we are 1,400 people. And we are quite big, actually. What our activity is, we design, we build and operate the Orange France data center, and we operate as well the internal network, all right? We've got something like 1,500 applications spread among different data centers, but we want them to we want to gather them into 3 main DC, 3 main data centers. This is one of our biggest projects, but I will talk about this a little bit later. Okay, so we are big. Sorry, not work. Okay, it's working. Okay, so every year our department manager publishes an energy and environment ambition letter. Okay, this letter gives us the direction to follow and set objectives, which lead to concrete action based on these 5 points. Let me explain what we are doing. Sorry, it's not working well.
Hey. Check mine. Just this quick one. See whether that works better.
Maybe it's not okay. And to go back, how do we do? Yes, all right. Okay, sorry for that. Okay, the first point. Sorry for that. This is going to be the boring part, but I will do as fast as possible, right? So to become more environmentally responsible, we have to get measure of our implication, of our emission, and the improvement we are doing, all right? So getting certified by international standardization is a way to follow, okay? This is one way to follow. And I will talk about 2 of them. So the first one is environmental management standard. In a very concrete way, it means that we are able to follow and to measure the impact of our activity, like for instance, purchasing IT equipment on environmental issue categories, all right? Like for instance, water pollution, air pollution, natural resources, and so on, all right? And believe me, this is a huge task to get published every 3 years. So, all right. The second one I would like to talk is energy management standard. It's aimed at improving our energy performance and reducing its use, right? So, the best illustration of it is that we are deploying new data centers. I already talked about this, all right? And with a very high effective level of performance, all right? So by this meticulous work, we are following the good path to get measure and to get improvement on our activity. If you have any question. If you want me to detail the second part about energy.
Yes. How do you measure efficiency of data center?
Let's measure it. Okay. I'm going to talk about the power usage effectiveness, all right? The power usage effectiveness is the total amount of power needed on your data center related to the power needed for your IT equipment in your data center, okay? So a PUE of 1, it means that you have a perfectly efficient data center. Of course, it doesn't exist, but in our modern DC, we have a PUE of 1.3. As a comparison, in our older one, we have a PUE of 2. And for some of them, higher than 2, all right? So now you can easily understand why you are involved in such a project to deploy and to build 3 big main data centers, okay? The improvement based on scope 2 is gonna be huge with that. Boring part is over. Okay, let's move on to the second point of the ambition letter. Each new project needs to report at the beginning of their life, at the beginning of the project, the carbon emission that will be created during the whole life cycle of the project, okay? We have to do this, everyone. For instance, in our private cloud version 2, we estimate that we are gonna create 200 tons metric of CO2 per year, according to our internal methodology. And here is an example of a simplified report we produce. Actually, can I a laser to spot? No?
Not
It
sure.
doesn't matter.
This has another laser, but oh no, it doesn't. You have to use this.
Yeah,
Not sure
okay.
it does.
There you go.
Does it?
Top one.
Okay.
Right here.
Top button? All right. So as you can see here, based on scope 2, we are gonna create 250 tons metric of CO2, right? For the whole life cycle, during the whole life cycle of the infrastructure. And as you can see here, based on scope 3, we are gonna produce 750 tons metric of CO2 during the whole life cycle of the product. So overall, 1,000. All right. And why we are doing that? Why we are doing that? For 3 reasons. The first one, it makes us aware of our own carbon emission, okay? The second one is that you can compare with other projects. For us, it's quite difficult because we don't build a private cloud every 2 weeks, okay? But for application project, this is really easy to compare. Okay, what are you gonna do? How efficient you are, and so on. And the third reason we are doing that is that we can make progress over time. Like for instance, for the private cloud version 3, we can say, okay, it was not so bad for the second one, okay.
And maybe one thing is that this kind of information is not easy to find, right? So thanks to Orange to actually sharing that. It's very interesting to see the kind of amount we are talking about into this kind of project, okay?
Just check the time. All right. Very quickly, that one, I will skip that one, but I just wanted to say that I already talked about the power usage effectiveness, so I will talk about water usage effectiveness, and due to free cooling, actually, our water usage effectiveness is very close to 1. So water usage is actually simple. This is the amount of water needed in your data center related to the amount of water needed by your IT equipment. Okay, free cooling, don't need our IT equipment, so close to 1. Okay, I'll skip that one. Okay, this is my favorite part. This is the funniest one. 4th point. At the beginning of the year, we wrote a purchasing handbook. Actually, I didn't, but some people did. We wrote a purchasing handbook with only environmental consideration. And sorry for keeping the details private, actually, but what you have to know is that the financial amount will be between Orange and a partner of a financial deal, actually, the highest environmental consideration are. So, if we feel that our partner does not suit with our environmental requirements, we can refuse the deal. there will be no deal, actually. And actually, right now, we are focusing on sharing this handbook, and we are grooming our employee because this is a technical handbook, all right, with many scales and so on. But for the next year, we want that handbook not to be a recommendation anymore, but a duty to follow. Next year, maybe it's soon, but in 2 years, we hope that it's going to be a duty to follow. Last part, promoting reuse. Quickly, I would like to explain what is refurbished equipment and reuse. Okay, refurbished, this is a product that has been returned to the manufacturer, which replaced the faulty part and sell it again. And reuse, this is simply the action of using something again. In our, sorry for my voice, in our entity, we managed to cover the need of new material up to 10%, all right? We've refurbished and reused equipment. And for this, to achieve this, we implemented an internal marketplace in which you can reallocate old equipment inside and outside the company. To be completely honest, this internal marketplace for us, it's quite difficult. For two reasons. The first one is that getting new materials, appropriate materials, it's quite hard actually. And the second reason is that because we are already trying to use our equipment until the end of life, we can reallocate our old equipment, especially the compute equipment. So it's over for the ambition letter and what some concrete action for this. I will end this journey by talking about my team and my activities. Yeah, okay, time is okay. Quickly, what we are doing, we are offering 4 types of infrastructure, but one of them is a non-cloud infrastructure. And we are managing something like 48,000 VM. Okay.
48,000 VMs. We're not talking about small scale. Yeah.
Yes, you're right. All right. So even then, this can be obvious for most of you. I would like to talk about virtualization. As shown here, a physical server consumes on average 5,000 kilowatts per year. If you virtualize it, you can divide it by 4.4. And the key point is that if you are moving this VM into a private cloud, like we offer to our customer, you can divide this amount by an extra factor of 7.5. So huge steps towards sustainability. Actually, no virtualization, no sustainability. This is simple. Okay, let's go deeper in our technical solution. The first one is about idle resources. Idle resources, we have 2 things. The first one, in 2022, we avoided something like 2 metric tons of CO2. Okay, it's small, but it's better than nothing, just by deleting idle VM. How did we do that? Thanks to PowerShell script, so fully automatic script process. After having identified the idle VM on our infrastructure, we simply shrink the lease of the VM to 1 month. And after this month, if the VM is still not working, okay, idle VM, it's deleted. Every month we are doing this, all right? And you have to know that we are doing this only on one of our 4 infrastructure. So we can make progress much more that we have done. The second point is about idle storage. On only one of our 4 infrastructure, we can delete. It's really close. We are gonna do this maybe in the couple of months. We are gonna delete something like 150 terabytes just by removing idle storage, non-used additional disk. All right, with the same process of PowerShell script. And thanks to this, actually, Why we are doing this? This is the key point, actually. Why we are doing this? We want to make progress on the scope 3, because if you are removing that, if you are removing these useless resources, you can decrease the amount of IT equipment you need, okay? So if you are implementing that at the beginning of the project, it's a good point, it's a good way to reduce your scope 3 emission by reducing the amount of IT equipment you need. That point, just check, okay, I have time, okay? So the third point we implemented in our infrastructure, this is the power management. I will let Valentin talk about this, but what you have to know is that this is really easy to implement with some high benefits, I will say, all right? What you have to know on this is that we implemented this without any impact on the performance of our application. So it's free, actually it's free. And the fourth point is about distributed power management. As you can see here, okay, 40%, it seems absolutely huge, right? But to be honest, we have to say that we enable this only on one of our 4 types of infrastructure, and this is the non-cloud infrastructure. Why this is so efficient? Because we have something like 15 VM inside the hosts, so it's easy to reduce. Oh, sorry, I forgot to explain what is the distributed power management. Let me come back just a little bit earlier. The distributed power management allows a DRS cluster to reduce its power consumption by powering on and off your hosts based on resource utilization. All right? It's absolutely magical. The less you use your IT equipment, you can turn off hosts automatically. And so that's why in our old infrastructure, this is so efficient, because we have like something like 15 VM inside our hosts, and on the 3 other infrastructure, because we have something like 150 VM inside, it's going to be less relevant compared to the legacy infrastructure. But this is a quite good one to make progress on scope 2. Because we have 150 VM inside, and based on the resource utilization, it's not going to be as relevant, because the resource utilization is quite high on our cloud infrastructure, you know? So you can't turn off your hosts, right?
And maybe we'll take the question at the end.
Yeah, maybe question at the end.
Otherwise, we won't have enough time, but we'll stay at the end.
I need to go, yes, this. And the final point I would like to talk about is, because we are offering transparent insight, we want to offer transparent insight to our customers into our impacts, generated by our activity. We have 2 kinds of reports. Yes, okay, sorry. The first one, we have used custom form in VMware ARIA Automation and VMware ARIA Orchestrator. We have used the custom form to display the amount of CO2 when a VM is deployed. All right. So when a user requests a VM via the consumer catalog, there is an informative banner which dynamically updates, reflecting the amount of CO2, the carbon footprint of the VM, all right? And this amount varies between small and larger size of the VM. So by size, we imply the number of vCPU of the VM, the amount of RAM, and the amount of and the size of the additional disks. The second report we are offering to our customer, thanks to Verialize, we can check and we can follow the electric consumption of an NSX. All right? And because we want to offer to our customer a unique platform where they can check the electric consumption of their infrastructure spread among different types of infrastructure, okay, because we have 4 types of infrastructure, we are offering a unique platform, and we developed a web portal to relay this kind of information. So based on their application, okay, the application is that you can see the total amount of power needed. We are at the end of this journey, and I would like to give you some tips to conclude this. All right? The first one, as you can see, as seen above, our top and local management are very involved, and they fix objectives, targets, and milestones. And if it's not the case in your company, you should try anyway to catch up with any existing move that is already existing to reinforce it. I tried to work alone. At the beginning, it's not working. So work in a team. Second one, about energy. As seen before, we have our carbon footprint is based on scope 2 and 3, mainly. All right? So if you are in a low carbon energy country, like France with nuclear plants, thanks to nuclear plants, you should focus on scope 3. Why? Because the biggest amount of your carbon emission will be based on purchase IT equipment. On the other hand, if you are in a high carbon energy country, like for instance Poland, sorry for Polish people, but focus on scope 2 and try to reduce as much as you can your electric consumption. I didn't mention it, but thanks to tons of training running into our company, our customers are more keen on getting smaller infrastructure, and that's a big point. Okay, they are keen on getting smaller infrastructure. If we can resume the new way of thinking in our company, is that it's okay to waste money, but it's not okay to waste CO2. And the last point, okay, it's gonna be very obvious for most of you, is that focus on features easy to implement with high benefits. But I couldn't make a stronger advice you to take a look at the power management, because as I said, this is really easy to implement, and that is why Valentin is here, and he's gonna talk about. And thanks for listening.
Awesome. Thank you very much, Thibault.
Thank you.
All right.
You need that, Atos?
No, I don't need a laser pointer. I will talk about host power management, so now the technical part. My name is Valentin. I work in the ESG office, in the office of the CTO, but my background is performance. I actually had my first talk at VMworld 2011, and I talked about power management. And at the beginning, I told everyone, for optimal performance, you need to disable all power management features, because no one in the room has ever seen a power bill, and we all laughed. I am not making that joke ever again. Because now everyone in IT is painfully aware of the energy cost, at least for the last 2 years. So as Thibault already said, the amount of power you can save using host power management varies. In their environment, they've seen 9 to 15%, which is quite respectable. In other environments, I've had a couple of projects with customers that have regular European country office hour VDI environments, but they're not quite ready to shut down these hosts using DPM, and they're saving up to 20% of energy by using host power management because, well, VDI machines are usually only running during business hours for that customer. But I've also worked with different type of customers, HCI environments, so highly integrated vSAN, NSX, highly utilized, and even in some telco environments where we're making progress in optimizing power management, well, we saw 4%. Now that might seem small, but if you're looking at a scale of multiple thousand hosts, that can be a lot. But I'd argue even if you're in a small environment, even small savings are worth it because it's so simple to implement. Now, this chart looks a little bit complicated. I want you to ignore the staircase. Just look at the graph. And the right side, on the bottom, you see the CPU utilization on the x-axis. On the right y-axis, you see the power that is saved when you compare a high performance and a balanced policy. And as Thibault already said, they have not seen any performance impact, but I will get to that in a second. The point is, when you're using host power management, the more underutilized your resources are, the more power you can save. Now, this is CPU utilization. It's actually more closely related to the number of wake-ups. But at complete idle, you can save 30, and in some cases 40%, but for this particular set of hardware, 30. If you're running at 20% utilization, you can still save up to 10%. So what I'm trying to say here is if you're running your hardware highly utilized at 90% plus, host power management won't do much for you during normal operations. But even then, your hosts are probably not utilized at all times. Sometimes during the day, they will be less utilized. Now, let's talk about risk. As Thibaut said, this was super simple to implement, and nothing is ever super simple. I have spent months in meetings about the discussion of risk and power management and performance, and usually when you group a risk factor and the benefit factor into a simple Gardner quadrant, right? If you have high risk, little benefit, you're not going forward with it. If you have high benefit and little risk, you would. I'd argue that host power management falls so little or falls so small in the risk part that there is no reason why you wouldn't proceed in implementing host power management. Has anyone here heard of power management? Has someone here performance as their main criteria? And of course, business operations or business continuity is a lot more important than efficiency, right, on the scale of risk. But power management really is not about power efficiency or performance, but you can achieve both at the same time. So it's not either or, you can have both. Is it operationally complex to change? It depends. How well do you interact with your hardware team or with the team that is responsible for BIOS configuration of your servers? Good relationship, you do it yourself, pretty straightforward. So I'd argue it is not that hard to change policies. Do you think you can only control it using hardware level controls, that you have to power cycle your systems if you have to decide between power efficiency and performance? No. All of that can be done at the API level whenever you want to retain full 100% control. And is it complicated? If you ask me, I've done this for 10 years, it's not. But there are some concepts that are involved that might require a little bit of soaking in. But I hope we can cover the most important ones here to your satisfaction. The main requirements that I argue we'd have to have is the impact. You don't want any impact, or maybe not any, but the least possible impact by default while still having some sort of efficiency semblance. But the most important part, I would argue, as someone who just yesterday wore an extreme performance t-shirt, you need full control. If there is any reason why you need maximum performance, no power efficiency, you should be able to do that within a second. Whether that's a break glass mechanism or whether there are applications that are more sensitive during certain parts of the day. It's critical that you do not sacrifice performance and business objectives. And the way how we went on implementing HPM, or how we implement HPM at pretty much any customer, is that first we go into discovery. In, I'd say, 99% of the customers I worked with, the host power management configuration is not the same across environments, across hosts. Hardware is managed by different teams and parts. So the discovery process, and by the way, on the bottom there are VMware short links. This is a PowerShell, a PowerCLI script that I wrote that just grabs the information, the technologies that are visible by the ESXi host, and that makes it easy to compare the assumption of configured policies based on a couple of key criteria. You need to figure out where you're at and where you want to start. Now, the ESXi policy, we'll talk about that a little bit more, but the default is balanced. Now, balance doesn't do much if the BIOS is not configured properly, but you want to make sure that balance is configured if you want to do effective post-power management. When you configure your hardware, I would usually start within a cluster. Depending on your risk, let's say, sensitivity, I would just go with a full cluster by yourself. But there is no problem whatsoever on just configuring half a cluster. So you always have the opportunity to use either vMotion to double check for performance. But my argument here is that you should never have to do that. Switching between the ESXi policy, balanced and high, will give you 100% of your performance back if you follow these few simple steps that we go to in a second. And scale, scale slowly. I have to say that. I would obviously recommend you that you just do all of the changes in the, right at the start. But scale by hardware type, because the largest, I think my phone is just going off, but you can't hear it, great. And start with def, of course. And beyond what we're trying to explain here, if you're using a balance policy, you can create a policy where ESXi is even more power efficient. And you can run these at different times of the day. For example, you have the balance policy with no performance impact, but if you don't mind that there's a performance impact later in the day, you can just put it to a low or lower performance policy and save even more energy. Also, if you have different control levels for different types of servers and you want to save more power, you can do that too. Now, people ask, so how should I configure my BIOS? Is there a one-size-fits-all policy? And I want to say there is, or at least as close as we can possibly get while still avoiding the risk that we talked about. And if you take one picture, that is the link where I've written how to do that, just in case I don't get through it in the next 10 minutes, but I will. So I call this no-risk host power management. The more accurate term would be low to no-risk power management, but that doesn't quite sound as nice. The key aspect here really is the same across any hardware type, any vendor. Whatever power management policy gives you best performance, whether that's called max performance, low latency, full determinism, no matter what it's called, you use that as the base, as your baseline. You set it to a custom policy, retaining all of the same settings, and then you give ESXi control over the features it can control. None of the features it can't, because then you don't retain full control. The process is the same for every vendor. And I've outlined it for 4 of the big ones in the block, but I'll add more as I come across them. Now, how does this work? BIOS power policy is usually a number of options and a number of values for these options, right? The difference between policies is different values for these options. But you have power policies on both levels, hardware and ESXi. On the hardware, you have max performance, dynamic, low power, all kinds of policies. And at ESXi level, you have high, balanced, low, and of course custom. I'm leaving low out of here because balanced is just fine. Now, when you combine these different types of policies, you can have different outcomes. Now, it's not as simple as a straight line between maximum power efficiency and maximum performance. It's more complicated than that. There are some settings for some workloads where you have maximum power efficiency and maximum performance without any impact. But just for the sake of argument, let's just assume performance and efficiency are different sides of a spectrum. When you choose maximum performance, no matter what you do in ESXi, high, balanced, custom, you will always have maximum performance as the outcome, because ESXi doesn't override the decisions of the BIOS. Right? We demark at that level. If you say maximum performance in the BIOS, ESXi is not touching anything. If you have a dynamic low power policy, you can actually control some of these features, but you will never have maximum performance. And many people run with dynamic power policies and wonder why from time to time they have inexplicit performance problems. Dynamic power management policies are a huge part in that. Yes, they're very power efficient, but they also risk performance. Now, you have more control doing that if you use an OS-controlled policy in the BIOS. So the BIOS has different presets, and you can go give it to OS control. That might give you very good performance, but not necessarily maximum performance. But you still retain full control using ESXi. Now, what I'm proposing is if you really want to eliminate all possible risk factors with a custom policy, the main goal here should be that if you choose ESXi high, you should have the same as the maximum performance power policy, no risk involved. So you always have full control. And you should have, of course, the ability to control and use different settings, but you will never really achieve maximum performance efficiency. And I argue as a starting point, you should be performance conservative. You can always introduce more risk factors later on, but when you start out, you want to avoid as much as possible. Because imagine you're running an efficiency project, and all of a sudden, your ERP system has a 20% performance impact. That will be the last time you had an efficiency project with that particular feature set. So, how does this work? Well, the options in the BIOS are usually have different defaults. Performance defaults, efficiency defaults, or in some case, OS controllable defaults. When you choose a maximum performance power policy, all of these options will default to their maximum performance defaults. If you're using a dynamic low power policy, these options, for the most part, will default to efficient options. Some might be ESXi or OS controllable, and some might be somewhere in the middle ground. When you choose an OS controlled policies, and again, the name differ across vendors, performance per what, performance what OS, right? The names are different, but let's just say OS controlled. You will have performance options or performance values. You will have OS controllable values, but you will also have some middle ground values, and there where it differs from the maximum performance policy. So again, the quite straightforward solution here is you configure everything to max performance with the exception of the settings that ESXi can control. And ESXi controllable might be different from Linux or Windows controllable because there are certain arguments about the demarcation of features, uncore frequency scaling, CPO link management. There are ways on overriding these, and we're continuously working with Intel and AMD to define the behavior. So we know when the BIOS defines something, whether we can override it if you choose to override it. Because again, in some companies, hardware and operations are siloed. So if the hardware team says we make a change, should you be allowed to override it? I say yes. I think that you should have complete control at the operating or even to some extent the application level. Okay, how do we do this? Straightforward, you read the blog, you follow the instructions, and you're good to go. Congratulations. Thank you for coming. Now, the script I mentioned before is straightforward. It runs against a vCenter, against a cluster, but it allows you to get a good overview over your environment. But please, you have to work well with your hardware team, whether you use Open Managed, whether you use Clarity, whether you use OneConnect. OneConnect? OneConfigure, OneConnect? Yeah, OneConnect, right? You need a good relationship with them because ultimately they're responsible. And while it is possible, and if they say it is possible to control power management using these tools, it is. But for 80% of the options, you need a host power cycle. And you do not want to power cycle your host just to change a power option. So getting the configuration rate is important. And again, you can start out using ESXi high performance, and there should be no difference whatsoever to the maximum performance power policy. Changing it over to balance then should give you the results that you intended. And if you need any help, talk to your account team, talk to your TAMs, they will talk to us, or if you can guess our email addresses, feel free to email us as well. With that being said, we're at the end of our session with 4 minutes to spare, so if you have any questions. One question, of course.
For DPM, as you are stopping your host, did you check the number of times you can do it? Because the hardware has some limitation for the shutdown and power.
Sorry,
I understand you, thanks to DPM, you shut down some of your host power.
Yes.
So as there is number of cycles for the power on the host, the PSU, you cannot switch them more than a certain number of...
So I think the question you're getting to at is, so the shutdown for DPM is an ACPI shutdown, meaning there's always power at the PDU and PSU level. You're very right that the PSU cannot be, because of current inrush, right, you can damage the capacitors, and most power PSUs have a limit of 1,000 to 2,000 cycles. Now, the same limitations do not apply to servers.
Because it's not a real shutdown. It's not powered on. It's still powered servers.
Yeah, so the PSU is still powered at the PDU level, but so you have 5 volts going to the switch, right? So some vendors do have supportability limits on the maximum amount of power cycles. It's called a full thermal cycle. So whether you do a power cycle, like a warm reset, doesn't really matter. Most components can take at least low 10,000s EEPROMs, or the most sensitive components. But if you do a full thermal cycle, down to environmental temperature and back up, some vendors say there is a limit there. Now, some of the large ones do not, but do contact your vendor because there is a possible risk. I argue that that risk is minimal because we're talking data center temperatures. The temperature band for thermal equilibrium to go down and back up to operating is very small. It's not a robo environment in the back of a Humvee in the middle of a desert, right? So I think the risks are overblown for most vendors. And I talked to a large one that we used to work a lot more closer in the past, I'm not saying any names. They have said there is no limit on any of the power cycles. As long as you have warranty on your servers, we will fix it if it breaks. So.
Okay, I think we're at the end of the hour, so we'll stay here if you want to discuss. Again, it's an important subject. So thanks, Valentin. Thanks, Thibaut, for sharing all of this. Please tell us what you think about this survey. Let us know through the application, because if this kind of topic is important for you, we need to know so that next year we'll be able to again do other sessions about this. So thanks a lot for your time and have a very good day.